Neurodevelopmental disorders are characterized by deficits in brain function emerging during the developmental phase of a child. In many cases, neurodevelopmental disorders are known to be caused by a damage to the developing brain, as seen in some infections with toxins or trauma during childbirth. However, for genetic disorders, investigators have typically studied neurodevelopmental disorders through a prism of neuronal development. Our study challenges this view. Using our data, we now suggest that certain conditions that are linked to X-linked gene, such as the Rett syndrome and MICPCH due to Cas mutation, may actually arise from early loss of neurons rather than any defect in formation and development of neurons or brain. The unique pattern of inheritance and expression of X-linked genes allows the disorder to manifest as neurodevelopmental in girls. We are excited by this finding, since in MICPCH, the microcephaly progresses throughout infancy and early childhood, and early diagnosis and a possible therapeutic intervention is likely to be beneficial in MICPCH, especially in the first 6 years of life when brain is still growing. Can our discovery help older children beyond 6 years? We also have found that in MICPCH, neuronal loss due to Cas deficiency does not result from cell-intrinsic deficit of Cas, thus pointing to a toxic extracellular process. Therefore, it is likely that dampening of this extracellular process is likely to improve overall functioning of brain. Although brain stops growing in size after 6 years, it remains highly plastic. So any new treatment modality targeting the toxic process is likely to be useful to older kids. Finally, such a treatment will be immensely helpful to those children or even adults who exhibit regression and appearance and or worsening of symptoms such as seizures. Thank you.